So now let's take this new integral going from y, z, x, because going from z, y, x was really bad, right? So hopefully this is a little bit better to look at. Let's find out. Okay, so now it's everything in terms of just x's, right? So our function is just x squared plus y squared. Now, we also got to change it up as well, because our function is x squared plus z squared, and we can't have that happening. Yeah, I guess we can. We can leave it like that for now. So if we do this triple integral, so we take the integral, I'll just rewrite it here for our sake. So we take the integral with respect to y now. This is nice because nothing's with respect to y, so it's just going to be by itself. So it's just going to be y times all of this. Evaluated at 4 and this part here. Now you may think this is really, really, really bad, right? So it's 4 minus this, so I'm going to simplify this to be looking like, oh, let's just make it somewhat easier to see. Okay, now you may think, why? And you may be thinking, yes, that's why. However, whenever you have something squared with something squared, polar coordinates is the way to go. Now, the difference is, when it comes to our polar coordinates, x is still going to be itself, but z is going to be a replacement for y. It really doesn't matter what it is, right? As long as we have two variables, we can convert it to polar coordinates. So now if we convert everything to polar coordinates, which makes this a little easier to look at, because now cosine squared plus sine squared equals 1. So this part right here ends up being the square root of r squared. This part over here, if I factor out a negative, this is also just r squared. So this ends up being just 4 minus r squared. So now all we have to do is just change our bounds of integration. All right, well, let's see what's happening, right? So if we go back to our circle here. So everything in terms of r and theta. So again, this will just give me 2. So the radius goes from 0 to 2, which makes sense. And we're going all the way around the entire unit circle, or the entire circle, so it goes from 0 to 2 pi. So our bounds of integration from theta and r end up being from 0 to 2 pi, and from 0 to 2 of our new function of just looking at it like this. And the square root of r is just r. And since we convert it to polar, we got to multiply by another r. dr d theta. And then simplifying this a little bit more to look at. And distributing. So this gives you r squared times all of this. And there we go. So integrating with respect to r gives you r to the third, r to the fifth. And now again, 0 gives give nothing, so you just plug in 2 respectively. So 2 to the third power is 8, and 8 times 4 is 32. And 2 to the 5th power also gives you 32. I'm just going to leave it like that for now. And we're going to integrate this with respect to 0 to 2 pi of d theta, which is itself. So nothing really matters, right? So the whole point is we just multiply by 2 theta this result. So subtracting these two fractions just gives us 4.23 approximately. So evaluating this at just 2 theta, 2 pi when I'm talking about theta, just gives us 8.46 pi. And there's our answer.